The scene at Mission Control on the 19th of October 2016, when ESA's first ExoMars mission, consisting of the trace gas orbiter and Schiaparelli lander, arrived at Mars. Unfortunately, the lander received unexpected sensor data during the last stage of the landing, which caused it to crash into the surface. But with its instruments successfully tested, the trace gas orbiter is in good shape. Its mission is to study the planet's atmosphere, particularly methane, which was first discovered by ESA's Mars Express.
The trace gas orbiter is really looking at active processes ongoing on Mars today, and life, present life, is one of the possible explanations. So it will be really a Sherlock Holmes work to try to put together a case for whether it's geological or biological activity that is responsible for the methane.
Before the trace gas orbiter can begin that investigation, mission controllers need to maneuver the spacecraft from its highly elliptical orbit into a circular orbit. And that's not easy.
We have to slow down, we have to brake. And since we have not enough fuel to brake with our engine, we use the atmosphere to brake.
The aerobraking process to gradually adjust the spacecraft's orbit will take more than a year. It's complicated by the changing nature of the Martian atmosphere, which expands and contracts, slowing the spacecraft by differing amounts.
We have to take a lot of margin to be sure that even if we go through a moment where the atmosphere is more dense at the altitude where we are flying, we are still safe with the spacecraft.
Meanwhile, plans are well advanced for the ExoMars 2020 mission, with the final design of the rover nearing completion. As well as a sophisticated vision system and next-generation analytical instruments, it'll be able to drill 2 meters beneath the surface. And scientists have shortlisted 2 possible landing sites to put it to use.
We want a landing site that is ancient, because the hypothesis is that conditions on the surface of Mars 4.3 to 3.9 billion years ago were similar to those on Earth when life started here. The second condition is we want a site where we had liquid water present over hundreds of millions of years. And we want this liquid water to be what we call low energy or slow flowing water, like on the canals in Amsterdam.
Together, the 2 ExoMars missions offer the best chance yet of answering the question, was there ever life on Mars?